Okay, so let's look at this problem, which looks a little bit more complex, but really isn't that bad. So we have crude oil that has a viscosity of 9.52 times 10 to the negative 4 pounds second foot squared, is contained between two parallel plates. The bottom plate is fixed. The upper plate moves when a force P is applied. If the distance between the two plates is 0.1 inch, what value of P is required to translate the plate with a velocity of 3 feet per second? And the effective area of the upper plate is 200 inches squared. So one of the first things that we need to do is we need to write down the given information, and this gets really important with problems where we don't have the symbology in it. So that's why it's important to know what these different things are. So we have viscosity, which is going to, getting ahead of myself here, let's roll that back. Come on. So we've got viscosity. Viscosity is mu. 9.52 times 10 to the negative 4th pounds second foot squared. So the bottom plate and the upper plate, so it's just our same Couette flow. So we have the distance, the gap, h, is 0.01 inch. And we have some force P that's being applied. And that's actually what we're trying to find. What is P equal to? And we do have a velocity. Our velocity is 3 feet per second. And we have the area of the plates, 200 inches squared. So this is where we have to go back to our other class and figure out, well, what is P? P is some kind of load. P is going to be what's driven by the shear stress. Shear stress is a force density. So our load is going to be equal to what? Well, it's going to be the shear stress times the area. So just like from our class that we've taken before, and we also know that our shear stress is the viscosity times du dy. And so I can, since it's Couette flow and we know it's going to be linear, that's just going to be viscosity V divided by H. So what I'm going to do is I'm going to take all this stuff, I'm going to plug it right in there for tau. So our pressure is going to be equal to mu V over H times A. Now as I look at that equation, I know all of that. I know viscosity, velocity, height, area. I can just directly solve this equation. 9.52 times 10 to the negative 4 pounds second force squared. And multiply that by the velocity, 3 feet per second. Let me get rid of the arrow here for right now. 3 feet per second, we're going to divide that by 0.1 inch. Once again, that doesn't work out with everything. We do need to convert that over. So we end up having to pick one of these. And I think it's probably easiest if we convert over the feet squared. So in order to convert the inches to feet squared, we're going to have to go here and go 1 over. And then we have our guy here. We've got 1 foot divided by 12 inch. And let me get rid of, make a little space here so we've got room to do things. So that's all gone. And now we're going to multiply that by our 200 square inches. And then we also have to convert that over. So we've got 1 foot divided by 12 inches. And then we have to square that to make sure that we have inches squared and feet squared. So what happens with all of this? Well, if we start canceling things out, that inch will cancel that inch squared will cancel that inch squared, feet squared, foot, second. So all the units cancel out except for the pounds, which is what we should expect because we are getting a force. So my load, if I plug everything in, is 0.476 pounds. Box that up, and that's how we solve that problem.